Hello, welcome to the world of sensors and sensing systems. So as you can see, we have lot many sensors on the screen and in everyday objects or products we use. We have electronics in it, whether it is our smartphone, our laptop, TV, or radio or smartwatch, or even when we drive our electric vehicle like electric car. So you have a control electronics there, and in that you have, as a part of electronics board, you have so many sensors inbuilt. So in a car or any smartphone you have about 10 to 100 sensors, so depends on the your vehicle and all that. So here on the screen you see that the first category is ultrasonic sensor. So it has one transmitter, it has one receiver, and it operates on the principle of sending and receiving the ultrasonic waves into its surrounding. So it is used in application to detect an object, to detect the positions and movement, etc., and it generates an proportional electric signal in response to the ultrasonic waves that it receives. Next category, as you can see, is a gas sensor. So you see that there are various gases in the environment such as oxygen, nitrogen, hydrogen, and there are gas molecules. So it's basically this kind of sensor works on the principle of it receives the molecules of those gases, and it measures the concentration of those gases in the environment or in the industrial context, and it generates an output. Then there is this color sensor. It is on a small breakout board or called as small PCB, and it is used to detect various colors or changes in a color. Again, it will detect those changes or the colors and generate a proportional electricity. It is also called as an optical sensor. Now you have, like, say, accelerometer. Whenever the object is moving, there is a motion. When there is a change in motion, you call it as a velocity, and when there is a change in velocity, you call it as an acceleration. So this sensor is used to measure the changes in the linear velocity. That's why it is accelerometer. Then you have, like, potentiometer is simply a variable resistor. So it is used in applications such as robotics for force sensing measurement. So whenever there is a bending or twisting of the arm or an object, it experiences a force, and because of that bending some resistance will change. That resistance can be measured. Then you have this infrared sensor. A very common example is our TV remote control. So you basically switch on your TV and operate your TV. You can switch off your TV. So basically you send an infrared pulse to your TV, and from this sensor module, and then you also can control it. And one part of this breakout board is to send infrared short pulses into the environment, and second part is used to receive the infrared signals or the radiated or reflected signal back, and it generates the proportionate electric output. Here is your flex sensor. These are rest of all the sensors are the solid state sensors. They cannot bend, but this sensor is flexible and bendable, so therefore it is called as flex sensor. Again, you see that there is this conductive element. So whenever there is a bend, the resistance of the sensor changes, and that is used to measure force, pressure, etc., or strain. Then there is this small sensor called as light dependent resistor, LDR. Again, it works on the principle of detecting the changes in the ambient light, and accordingly it varies its resistance. Thermistor, again, as the name suggests, it is a temperature sensing resistor. It detects the changes in an ambient temperature or a temperature of a particular environment, and it changes in response to that its effective resistance. Then there is a red sensor, so whenever there is a red drops, it changes its resistance accordingly. It works on that principle. Then there is like IR transmitter, so this is basically a part of this sensor right here. You have a photodiode, as the name suggests, it is like photodiode. Light falls on it and it conducts an electrons through it and generates an output voltage. Then you have this small temperature sensor. Then you have this microphone which works on the principle of acoustics. Then there is a magnetic sensor called as Hall sensor. So Hall sensor, it is used to detect the changes in its surrounding magnetic field and generates a proportional output. Microphone is used to detect the sound waves. For example, I am talking to you through this video and there is a mic or a microphone is receiving my sound waves, and it converts that sound pressure into proportional electric output. So that's all. So you got a comprehensive understanding about various types of sensors that we use in modern day electronics systems. Hope you understand the working principle of which all of these sensors, they work, and after they perform their function they can be integrated with the embedded electronics such as microcontroller, very popular board known as Arduino 8-bit microcontroller. So you basically have their analog output. All of these produces analog output, and that analog output then is received by the microcontroller board. First function of the microcontroller board is the inbuilt ADC. If it has, it converts the analog into digital, and then microcontroller processes that digital signal and accordingly provides us the output in the form of a display or a computer screen, or it can transmit the data wirelessly, or on the computer screen on the cloud environment it can store that data. And that data, understanding that data, analyzing that data, we understand what we are measuring, how much is the concentration, how much is the magnitude of that physical quantity. So I hope you like this video. You can like the video, click the like button, comment on it, and subscribe to our channel and share it with others who can benefit. And till then, stay tuned for more informative content, and wish you happy learning.